Okay, we're having to start where we dropped off. So we were on the one that says y equals -1 sine x. So the -1 goes with the a. So we know that if a is less than 0, it's going to reflect across the x-axis. So our original sine function looks something like this. So the red one is our original one, and then the blue one is going to be where we flip. So from this dot's going to flip down here, and this dot's going to flip up there. And so then we have a graph that looks like that. Now, sine and cosine are basically the same idea. They just have a different basic function. So if I give you one that looks like this, y equals 2 plus cosine x. Y equals 2 plus cosine x is the d. This is the d that's outside. So outside the function moves our graph vertically, up and down. So in this case, it's going to move it up 2. So we start with our basic cosine graph, which we know looks like this. So this is y equals cosine x, and that's the one that we did with the different basic graph. So now we're going to do the same kind of idea, but this one's got a d involved. So we're going to start with our graph. Here's 1, and here's -1. So we have, starting at 1 for our original graph, it looks like this. Comes down here like this. So this is our original graph. Now, plus 2, everything goes up 2. So this 1 goes up 2. This 0 goes up 2. This -1 goes up 2. This 0 goes up 2. And this 1 goes up 2. So it's basically like just taking it and moving it upward. So then we have the y equals 2 plus cosine x. Okay, give everybody a chance to catch up to that. Okay, the next one we're going to look at after the A. We've done the A and we've done the D. Now we're going to do the B. So we have a graph that looks like this. We're going to graph y equals cosine 1/4 x. Now, y equals cosine 1/4 x. So our 1 is our amplitude, so that's just going to be the regular graph. But now the 1/4 is our b. So if b equals 1/4, then we said before that the period was going to be 2 pi divided by b for sine and cosine. So 2 pi divided by b. So to divide by a fraction is the same thing as multiplying by its reciprocal. So we have times 4/1, which gives me 8 pi. So I know my cosine, my basic cosine graph, goes to 2 pi, and then comes down and looks something like this. So I'm going to recreate this same shape, but I'm going to go, instead of from 0 to 2 pi, now I'm going to go from 0 to 8 pi. So I start out with graph. So there's 8 pi, and here's 0. Now we didn't have any horizontal shift. All we had was the difference in the period. So our original sine function graph Let's label these off first though. So this would be 1, 2, 3, 4 pi, and this would be 2 pi, and 6 pi. All right, our original graph of cosine would go from here because the period for cosine is 2 pi, right? So this is 0 to 2 pi. So if I want to do the new one, and it's 8 pi, I still start at up 1, and I still end at up 1. Halfway between, I could still go down to -1. And halfway between here, I cross the axis. So it still looks like this 1, 1, -1, cross the axis, cross the axis. But what it does is it just stretches it out. So it still has that same curve, but it stretches it out. So if we had something like a b equal to 3 instead of a b equal to 1/4, then my 2 pi divided by b would be 2 pi over 3. So my new period in something like that, so if b was equal to 3, then we'd have something that was shorter. So instead of stretching out like this, then we would squeeze it in. So the b affects the period, so it either widens it or makes it not as wide. Okay, so now we're going to look at a C one. So we've done A, we've done B, we've done D. So now we're going to look at a C. So C is inside. So if you remember from your notes a minute ago, it looks something like this. A sine B, x plus C plus D. So C is on the inside. So that would look something like this. Y equals sine x minus pi over 6. Now, this right here tells us, we said that you would think negative pi over 6 would move you to the left, but we said that the horizontal part is the opposite of what you'd expect. So really it's going to move me right pi over 6. So I'm going to start my picture at right pi over 6. So we're going to draw our picture. So if I'm going right pi over 6, that's pi over 6. But then now I have to create the 2 pi to go to the end. So I'm going to go 12 pi over 6, right? 12 pi over 6 would make 2 pi. So 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. So this would be 1 plus 12 would be 13 pi over 6. So halfway in between, we're going to make a mark. So we've got 1, 2, 3, 4, 5, 6. So this should be our halfway mark. 2, 3, 4, 5, 6. So what's this going to be if this is halfway between pi over 6 and 13 pi over 6? Well, this is going to be 7 pi over 6, right? Because I moved it over. So this would be 1, 2. This is 1, 2, 3, 4, 5, 6, 7. And this would be 8, 9, 10, 11, 12, 13. So we're graphing this time sine. So our basic sine function again looks like this. So we start at 0, we end at 0, and 0 is halfway in between. So we're going to start at 0, end at 0, and be halfway between at 0. So now what do? We're doing the sine function. So halfway between the first two zeros is your high point. So since our A is a 1, we're still going to go up to 1 and down to 1. So halfway in between would be here. So there's going to be the up 1. And here's going to be the down 1. So my new graph is going to look something like this. Now, I want you to make sure that you label these spots. So this one was everything moved to the right, pi over 6. Now, we've done the A, B, C, and D for those. Now we're going to go back and look at our graphs that we made. And we're going to look at the other 4. But before we look at the other 4, I want to mark something on our picture. So when we draw one complete period, we're going to be drawing one complete period. It's going to be on this one. It's going to be from here around to here. So that would be one complete period. So when we're recreating our graphs, that's what we're recreating. We did that with those other ones. With cosine, same kind of idea. One complete graph. One complete period would be that U-ish looking thing. Now, on tangent, it's a little bit different because we didn't write down what the period was for tangent. So the period for tangent is just going to be pi, and cotangent is just going to be pi. So period pi on this one and period pi on this one. Now, the reason why is because we said the period was where it was repeating itself. So if I look starting at 0, up, asymptote, down, then again, I have up, asymptote, down, so it starts repeating itself. So the part that I'm graphing is up, asymptote, down. So that would be the part that we would create for one period. So if I go up here to cosecant, this would be one period from, because then this would be the same on this side. And on here, one period would be like that. And then on this one would be, one period would just be this one piece, because then it does repeat. So see if I can center this and let y'all mark your papers. Okay, so now that you've got that caught up, we're going to see about drawing some other graphs that have transformations. So we're going to graph y equals 3 tangent x. Now again, this is my A, but A is on amplitude because tangent, you can see how tangent doesn't have a high point. It's going to go up there forever and down forever. So we have a different way of looking at the A for the tangent. So the tangent, when we graph the tangent, we said we were going to graph one complete period is the up asymptote down from 0 to pi. So this A affects how fast the pitch does. So this one right here, we went up to 1 and down to -1. So if I stick that 3 in there, it's going to cause this dot to go up to 3. So my picture is going to look something like this. So here's pi, and here's pi over 2, and here's pi over 4, and here's 3 pi over 4. So you have to get used to labeling the axes when we're doing these transformations. So we said it was going to start at 0, up, asymptote, down. So we're going to have an asymptote here, halfway between. And then we're going to have a dot again. So instead of going up to 1 at pi over 4, we're going to go up to 3. So we're going to go 1, 2, 3. And then this is going to go up. Now, I probably should have put them closer together. And this one's going to go to down 3. 1, 2, 3. So it's going to go down like that. Now, I could complete this more if I wanted to. I could add another up asymptote down 3 or 4 times, whatever you want to have, however wide you want your interval to be. But this would be one complete period. So the 3 affects how high the pitch is. The 1 would make it flatter as it's going up, whereas the 3 makes it a little bit higher pitch. Okay, let's try this one. Y equals 2 cosecant x. So now we look at cosecant. So this is my 1 period. Cosecant is 1 period. Now see how this pi over 2 went up to 1? Went up to 1. So all of these numbers inside went up to 1. So when I'm doing the number out in front of the cosecant, it's not actually, again, a high point, because cosecant has these arrows that go up and down. So our 3 or 2 or whatever it is we have, our 2 is going to go this distance between here and here. So this is like my A. From here to here would be like my A. So that's what we're looking for, is being able to do that. So we start out with I need to go from 0 to 2 pi because that's my period. So this would be 0, 2 pi. And this is going to be my half of the pi is pi, and this is pi over 2, and this is 3 pi over 2. So again, my basic cosecant function graph is this up asymptote down thing. So we've got the asymptotes on here and the u's on there. So we're going to start with an asymptote, just like our basic graph. We're going to end with an asymptote, just like our basic graph. We're going to have one in the middle. Now, normally we'd go up to 1, but now we're going to go up to 2. So we'll go up to 2. Make sure you label the axes. And down to -2. So this one over here would be down to -2. So I go up, and I go down. So the difference between the original one, looking like this, and the one that we just did is the distance between here and here is going to be my A. Okay, now let's try a secant. So I'm going to have y equals secant 2x. So now this 2x inside here is my b, right? So that's going to be the b inside. So if I looked at my formula, the b is between the parentheses and the trig function. We don't have a c or a d or an a. Well, we do have an a. The a is a 1, but it doesn't change anything. So we know our secant graph looks like this: up, asymptote, down, asymptote, up again. So it has this one piece, right? So now we're going to recreate that with a different period. So I've got 2 pi divided by b, because again, our cosecant and our secant have periods of 2 pi. So let's go ahead and write that down on our picture. Period 2 pi. Period 2 pi. So my b is 2. So if I take 2 pi and divide by 2, now my period is pi. So I'm going to be doing the same thing that I was doing before, except now here would be my pi over 2, my pi, my 3 pi over 2, and my 2 pi, and that would be my original graph. But now, instead of going for the whole thing creating itself in 2 pi, now it's creating itself in 1 pi. So what we're going to do with this then is we're going to break this up into 2 pieces each. So what did we say? Half of pi over 2 would be pi over 4, pi over 2, 3 pi over 4, and pi. So now this, instead of having the whole 2 pi to recreate our picture, we're recreating just between here and here. So if our graph has an asymptote 1 step in and then another asymptote in 3 steps in, so we're going to have an asymptote here. We're creating just like it was before, and we're having another one here. So now that gives us the 2 asymptotes, and since there's no a in the front to change our distance away, we know it's just 1, so I'm going to go from my dot and approach my asymptote. And from down here, I'm going to go from my dot and go down, down. And then this one's going to go up. So you got to remember that this distance right here is going to be your A on both the secant and the cosecant. So if this had been a 4 in front, instead of me starting at 1, I would have started at 4 and gone up, and down here at 4 and gone down. So it depends upon what your A is. Now your A can also be negative as well in here. So like in this tangent one that we did, if this was a -3, then instead of everything going up, it would have gone down, and this one gone up. So just reflecting it across the x-axis. Same with this one. If this one had been a -2, instead of it going up like that, this would have come down. So you got to watch for those negatives. Okay, we're going to stop at that point right now. Thank you very much. Bye.